Good day, viewers. In this lecture, we'll be looking at non-exact on first order differential equation. If you are new to this channel, make sure you subscribe, you turn on the notification bell so that you'll be notified when new video drops. So in our last lecture, we talked about exact type. So we have a condition. We said that if you have this differential equation, dx plus n dy equals 0, where this partial derivative with respect to y is equal to this with respect to x. So we said if these two are equal, then the differential equation, this given equation, will be exact. So for non-exact, it is when they are not equal. So when they give you this same question and then the two equate this derivative, they are not the same. So we say that the differential equation is non-exact. So how do we solve a non-exact differential equation? So the idea is when you have a non-exact equation, we solve for the integrating factor. There's what we call integrating factor. So when we have this integrating factor, we'll use the integrating factor to make the non-exact equation to become exact. We solve for the integrating factor. After we have the integrating factor, we use it to multiply the differential equation and then we make it exact. Okay, so this is the kind of equation we are considering. So consider we are considering equation of the form dy ds plus p of y equals q. So p is a function of x, also q is a function of x. So equation of this form is what we are considering. So if you have a first order equation of this form, now your integrating factor is given as, I use I dot f as abbreviate. So integrating factor is given as integral exponential integral of p of x then ds. Okay, exponential integral of p of x then ds. So it is this p, the coefficient of y now, that you put here, p of x, then you have the ds beside of it. So this is your integrating factor. There are a lot of information to pick from this from this equation. You can see that the coefficient of dy ds is 1. It has to be 1, and your q is the one that doesn't have y. Look at the function with y as coefficient. The function of s with y as coefficient is the one we describe as p, while the one without the y is on the other side, is the one we describe as our q. Okay, so with that being said, let's look at an example. So we have this given problem and then we are asked to solve. So looking at this question and comparing it with the integrating factor, that comparing it with the non-exact form I gave you, you could see that your p is 3 and then your q is exponential 2x. So you could see that this equation is actually in this form, dy ds plus p of y equals q. You could actually see that. So with that, what is your integrating factor? That is what you need. Integrating factor is exponential integral of p then ds. So what is p? P is 3. So if you integrate 3, you get 3x. So that is the answer. So we are going to multiply. If we call this equation 1, so you say multiply 1 by what? By the integrating factor. So we have, if you do that, you have exponential 3x dy dx plus exponential 3y equals exponential 3x dot exponential 2x. This is actually exponential 5x. So let's leave it like that. I want you to take note of this, that this whole thing on the left can be represented as d ds into exponential 3s then y. So this whole thing on the left could be rewritten as this. So, and what does this mean? It means that the derivative of exponential 3sy is what you have at the top. So you know this derivative now. So derivative of this function inside is what you have at the top. So you are using product rule. So to confirm that this exponential 3s, you could see you leave it first. You differentiate y, you have the y ds plus. You leave y, then differentiate this, you get 3 exponential 3x. So now this is equals to 5x. Okay, so what is the next thing we need to do? But I want you to take note of something. When you multiply by your integrating factor, so on this left, you just have to pick that integrating factor, then your y. The integrating factor we got was exponential 3s, then you multiply it by y. That is all. Now, to get y, we are looking for y in this problem. To get y, you integrate both sides. So if you integrate both sides, okay, let me just do this now. Also have this, integrate both sides with respect to x. So if you do that, the d will leave, you have 3xy. This one will be 5x over 5 plus c. So what is y? Y therefore becomes 1 over 5 exponential 5x over exponential 3x plus c over exponential 3x. So this is 1 over 5 exponential 2x using law of indices plus c exponential 3s. So that is your y. So we are done. So let's look at example 2. So checking this, you could see that your dy dx can also be written as y prime. So this is your y, this is your q. So your p is -1, your q is s. You could see that it follows the general form of non-exact, the form we are dealing with. So now we need to get our integrating factor, which is exponential p dx. So the integrating factor is -1 ds, so you get exponential minus x. Okay, so what do we do next? We multiply. You can call this equation 1. That equation that you pick the p from is what you multiply by the integrating factor. So multiply 1 by what? By the integrating factors. So we have exponential minus s, then this minus exponential minus this, y equals exponential minus x, then x. So like I explained in the previous example, that you just pick your integrating factor and then you multiply it by y. So if you differentiate this using product rule, you get what is at the top. So after you've gotten this, you need to integrate both sides with respect to x. So integrating this with respect to x. So what do you get? You get this is equal to the integral of this ds. So to integrate this, let's use the di method. So it's faster and acceptable, the di method. So the one we are differentiating will be s, while the one we are integrating will be exponential minus s. Okay, so we'll differentiate this until you get 0. If you differentiate s, you get 1. This one is the one you are integrating. If you integrate this, you get minus exponential minus this. Integrate 1, you get, differentiate 1, you get 0. Then differentiate this, you have exponential minus s. We are done. So now you put plus minus plus. So this times this times this. Okay, so the integral of s exponential minus s will give you this s times the first one, minus s exponential minus s, minus 1 times the other one, you have minus exponential minus s. So the answer is minus s exponential minus s, then this plus a constant c. So y now, if you divide by this, you have minus s exponential minus s over this minus this over this plus c over this. So there are terms that could cancel. You have x here, minus 1, and here becomes plus c raised power x, because this minus s, if it goes up, become s. So that is your y. So this is your y. Okay, this is your y. So let's look at the last example, and this is where it gets interesting. So solve the that is the question. So solution. So now if you rush in this question and then say that, you can pause this video and attempt this question before you see my solution. So I believe you've done that, so let's continue. So if you say that your p is minus x here, you've missed it. So why is that? Remember, the form we are dealing with is this form: p of y equals q. The coefficient of dy dx must be 1 before you pick your p. In this question, there is something beside this dy dx, so you have to divide by this first. Okay, so that will give us one. Let's rewrite the question. So we can't use the question the way it is given. Okay, so we divide by this, so we have dy ds is equals to minus over 1 minus s squared, y equals 1 over 1 over s squared. Yeah, so it is of this form now that you can define. This is now 1, you can see. So your p is now minus s over 1 minus s squared, and this is your q. So with that, we can call this equation 1, because this is the equation where we derived our p from. So what is the integrating factor? The formula remains the same. So we have minus s over 1 minus s squared ds. So we need to integrate this, but observe there is a formula that says if the derivative of the denominator is at the top, the answer is the lane of the down one. Okay, so if you differentiate this, you get minus 2s. So there is s, but then there is no 2, so you can manipulate 2 in like this. So that is how you manipulate the 2 in. So if you push 2 inside, you have 2 minus 2x over 1 minus s squared dx. Okay, so integrating that, if you differentiate this, you get minus 2s. So with this formula, it will just be 1 minus s squared. Okay, so exponential and lane can cancel, but they can't cancel with this number in between. So you have to push the number up like this. So this will cancel this, so you have 1 minus s squared raised power 1 over 2. So that is our integrating factor. So we are going to multiply 1 by what? By the integrating factor. So what is 1? So we have 1 minus s squared raised power 1 over 2 dy dx. So next thing is 1 minus s squared raised power 1 over 2 x over 1 minus x squared, okay, equals to, what was q before? Q was 1 over x squared, 1 over 1 minus s squared. So we are now multiplying it by 1 minus s squared raised power 1 over 2. Okay, so this remains the same. I just want to simplify things. This cancel, this is 1 at the denominator, this is 1 over 2. You know, I want it to be like this. See, if you do s raised power of 1 over 2 divided by s, this will give you s raised power of 1 over 2 minus 1. Okay, that's s raised power of 1 over 2. At the end of the day, you have okay, let me just write that. So this is 1 over 2, this is 1. If you minus the power, you get 1 minus s squared minus 1 over 2x. Then I think there is a y here, sorry, I missed that. So same thing happens here. This is raised power of 1, so you have 1 minus s squared raised power of this. So this can also be written as 1 minus s squared raised power of 1 over 2. So that is just the point. So at this point in time, you can get this whole thing on the left can be written as dds into the integrating factor is 1 minus s squared raised power of 1 over 2, then you multiply it by y. Then this other side we have 1 over 1 minus s squared raised power of 1 over 2. Sorry, let me remove the integral I wrote there. Okay, so what do we do next? We integrate to remove the derivative. Okay, we integrate both sides. Let me just write the integral there. Then what? ds. So the integral of this is 1 minus s squared y. There's a 1 over 2. Okay, so the integral of this can also be written as 1 minus s squared square root ds. So this is a standard integral. The answer is ln of x plus c. It's a standard integral. So what is y? Y is equals to this plus c over 1 minus s squared raised power of 1 over 2. Alright, thank you very much for watching this video to the end. If you haven't subscribed, make sure you subscribe before leaving. Thank you, and thank you once again.